Hello, in this unit we are going to see an example of applying the properties of the real numbers, especially the advanced operations that we have seen. Here we have a relatively complicated mathematical expression where we have a radical, a root of order 12 and a fraction inside the radical. The numerator is raised to 6, the denominator is also a product of two powers. The idea is how to handle the integer powers as well as the fractional powers, to facilitate a little bit the handling of radicals, and to see how the properties really allow us to arrive at simpler and more manageable expressions. So we are going to start applying little by little the properties that we know to simplify this expression. Whenever we encounter a root, maybe this is generalizing a little bit too much, but let's say that practically whenever we have a root, what we have to do is to remove it and convert it to power notation. As we said, the 12th root is going to be interpreted as the power 1 divided by 12. So we can write exactly the same fraction, but now instead of the root, with the power 1 divided by 12. And now we begin to apply the properties of exponents. We have a fraction or an exponent, then that exponent affects both the numerator and the denominator. We see it like this: the 1/12 affects the top part and the 1/12 affects the bottom part in the same way. Now at the top we have n plus 1, which is raised to 6 and then raised to 1/12. Since we have a base raised to a power and then raised to another power, the exponents are multiplied. And we get that the numerator would be n plus 1 raised to 6/12. In the same way, in the denominator we have done the same thing. We had a product raised to a 1/12, so that 12 can go to each of the powers. It would be 27, 4, 27 raised to 4, raised to 1/12, and 4 raised to 6 raised to 1/12. Applying again the product of exponents, we are left with 27 to 4/12 and 4 to 6/12. When we have the fractional exponent, the ideal is to reduce the fraction to the minimum expression, that is to say, to go to what would be the canonical expression of the fraction, which is simply to remove the common factors in the numerator and in the denominator. In the numerator, n plus 1 raised to 6/12, the 6/12 is the same as 1/2. Therefore, the numerator is n plus 1 raised to 1/2. And below we can do the same. 4/12 would be a third, and 6/12 again a half. We go back again to radicals notation. Once we already have it simplified, at the top we have the root of n plus 1, which cannot be simplified any further, and below we have the cube root of 27 and the square root of 4. Remember that when the root is square, we do not write the 2. But the number 27, as we know, is 3 cubed, and the number 4 is 2 squared. The cube root is the inverse of raised to 3, the square root is the inverse of raised to 2, and therefore the radicals go with the exponents, and we can say that the denominator are 3 and 2. Therefore, what we are left with here at the end is the root of n plus 1 divided by 6, or what is the same, 1/6 times the root of n plus 1. So far this is a sample of how, using the fundamental properties of powers, we can handle really complex expressions like the first one and take much simpler expressions like the one we see at the end. That's all, thank you.